Hi guys, thank you all for coming today. I'm Ivan, this is Francisco. We are mobile developers at Shopify, and we have prepared another async continuation talk today. I guess the goal of this talk is to provide you some thoughts, some ideas about how to solve one very common problem related to async continuation execution. But before we jump into the problem itself and the solution that we would like to share with you, let's have a little bit theory. So how do we usually approach solving the problem? Basically, we start dividing the problem into smaller subtasks until they are small enough to solve them, and then we are combining the results, and it gives us the result for our original problem. So what does it mean, concurrency? Well, concurrency means that the application making a progress more than at one task at the same time, so it's executed concurrently. And what means that it improves the overall speed of the solving large problem. What does it mean, the asynchronous? Well, obviously we want to offload the task execution into some background thread, and we don't care how it will be executed. We will get we want to be notified when the execution finished with using some callback mechanism. And for the actually continuation, well, in asynchronous programming, it's very common when the one asynchronous operation on completion passes the result to the second asynchronous operation as the argument. So in other words, it's some kind of a mechanism of chaining the smaller task together in order to create the continuation execution of these asynchronous tasks, and at the end to get the result of the original problem. So let's just summarize. We're breaking the large problem into smaller subtasks. Each subtask executed the asynchronous. It could be executed concurrently. Each task can be resolved with two states. It's success or failure. And then we have some kind of controller that combines these resolutions of the task together in order to get the problem for the large problem. So I guess it's enough of theory for now, and I would like to ask Francisco to come up with some real example of the problem and provide the first part of the solution that we want to share with you, and I will continue the rest.
Thanks, Evan. Okay, so let's try to see if we can apply what we just learned to solving a particular problem. So we will test with showing some information about a customer on our Android device, and we need to fetch the customer, reference orders, and fetch the current checkout. And for each one of them, we have some attributes that we want to show. Now, using what we just learned, we will start breaking the problem into three parts. So the first part is to fetch the customer. The second part is to fetch the orders, and then we will fetch the checkout. Now, sometimes you can change, you have to work with whatever you've dealt. So we're going to have to use an old API that has no design patterns whatsoever, and you can change the API, which means you have to work with it. And the problem with this API, this hypothetical API, is that the fetch order by ID just works on one order at a time. So we need to make as many calls as needed for each order that we have. Now, fetch customer by ID will fetch a single customer, fetch checkout by ID will fetch a single checkout, and fetch order by ID will fetch a single order. All those tasks are to be asynchronous, so we cannot just wait, present something and keep the thread blocked or something. So we also need to take that into account. After all tasks are synchronous, we need to do something, some way to presenting them. This is our hypothetical architecture. So we first fetch the customer on the server, and then a bunch of data that comes back. And we'd like to do all of those tasks at the same time. So checkout's fairly straightforward, but we have an orders ID, which is a list, and then we're going to fetch one order per order ID at the same time. And you might notice that small exclamation mark over here, which means the API may crap out, right? It may even have an error, connectivity issues, whatever, so we need to handle that as well. I will propose 3 solutions for this problem. And the very first solution is something that most of you have done in the past, which is plain, simple callbacks, right? Now, as Android developers, we all know that UI thread is sacred, so you shouldn't hog it. You should just post status views stuff in there, but you can do like computations, network stuff, calls and stuff. So we're going to use callbacks, and we're going to use an Android mechanism for working with these callbacks. This is our hypothetical repository interface, which will provide the implementation for the network calls. And we will have one method per API. So fetch customer will return a customer, fetch order will return a order, and fetch checkout will return a checkout. This is a sample of some classes that will help us do our work. In this case, for callbacks, we're going to have at least 3 classes. One for orders, one for checkout, and one for customer. And we are going to use Android's async task, right? Because async task provides a nice and neat example of how we can do work not on the main thread. As you can see here, our async tasks work with a repository and a callback, which we were going to call once stuff is done. So this is our callback, which accepts a customer. This is our doing background method, which will call the API and return the customer. And once everything is said and done, we're going to call our callback over here, right? Recall that we have 2 more tasks, which are exactly like this. They just operate on a different object. One checkout, one on customer. This is a high-level sample of the code. I'm going to go. Can everyone see the code? Fine? It's okay? So we're going to go line by line to explain what's happening here. So the very first thing we're going to do is call the customer API. So customer async task, execute, and then this whole stuff will work on this repository, and then we're going to pass the first of our callbacks. And this callbacks accepts a customer as a parameter. So start fetching the customer. Once it's done, do the work inside the brackets. Once we do have the customer, fetch the checkout the same way. And for each order, as we said, fetch each order using the async task. Now, you may notice that there are purple variables here, which are state. So for every order that we fetch from the network, we save in an array list of some sorts. And once we have the checkout, we save it somewhere else. This is our awesome synchronization mechanism, right? We have async tasks running about. We have to somehow synchronize them to show the information when we have all the information. And this is the simplest way we can get. We create an atomic integer and set its value to the remaining tasks that we have. We have 1 task for the checkout, and we have n tasks for the orders, right? So whenever one callback finishes, we decrement that atomic integer. Once all is finished, we can show the customer info on the screen. Now, you'll notice that we have the block repeated because we don't know which of the callbacks will finish first. Maybe the checkout API will take like 10,000 seconds or something. So this is repeated. Okay, so what are the callbacks approach? So the first of it is that there is no learning curve required. It's just a plain old Android API. No libraries, no nothing at all. No dependencies. Callbacks are supported by default. You just download the SDK and you can start working with callbacks. we'll cover the majority of simple cases. You don't have to reinvent the wheel or create a mega awesome framework for doing simple cases. You can just use one async task and it will work, right? Now, the cons of callbacks are, so first of all, nesting. We saw at least two callbacks, two methods inside one callback. Now, imagine if we had to nest one more or two more, like one API depends on another, then depends on another, then depends on another. So once we start nesting callbacks, they become very difficult to maintain and read. Synchronization mechanism can be very hard depending on your callbacks. That atomic integer is very simple, but it's very like non-production code ready. Callbacks are stateful by design. If you cannot save your work somewhere to use somewhere else, you will lose that work. And you may notice that we have no error handling, and this is by design, because if we had error handling, then the presentation wouldn't fit on a single slide, right? We have 3 callbacks, and all of them can crap out with different errors. So it will be very messy very quickly. Okay, can we do better? Sure, we can try to do better. So the next solution, we will try to use a framework that does most of the heavy lifting for us. And that framework is called Facebook Bolts. So once again, we'll start with a repository that will abstract away network calls for us. And this repository looks the same. Now, we will return a different thing. So Facebook Bolts work with the concept of task. And a task in Bolts is a chainable thing. So you have a task, you can chain tasks one to another, right? So we have a task for a customer, we have a task for order, and a task for checkout. This is our sample code. So we will, as always, start by fetching the customer, and we will return a task, and then we will call onSuccessTask. OnSuccessTask is a method of the Bolts framework, which will only execute the function you passed if this is successful. If it does not work, it won't call. And you can see right here that this will be presented on the UI thread. All work on background, work presented on the UI thread. So, the success task accepts a continuation, which is Facebook's way of chaining stuff. And then we will, as always, fetch a checkout. And then we will fetch one order per order in that list. Now, pay attention that these are not order objects or checkout objects, they are tasks which operates on that type, right? So now we have a list of tasks for order, and we have one task for checkout. Once all said and is done, remember, this all happen at the same time, so this is parallel. And once everything is said and done, we will call that when all. When all is a special operator in Bolts that will operate on a list of tasks. And it will only emit something when all of them are finished with success. So once everything is finished, we will show the customer info with those results. And the result here is the method of Bolts that gets the actual variable type. So customer result, yeah, it looks weird, but yeah. Okay, so what are the pros and cons? So first of all, no callbacks, right? We didn't have to call anyone to present anything else, so that's good. It's composable, so we we chain operations together, one input being the output of the other. And Bolts operates in similar principle to promises. If you ever work with JavaScript in promises, it's kind of similar. You chain stuff together and then you wait for that stuff to finish. Now, Bolts, it's not very well known. I particularly never heard of it until the presentation when I said, hey, try Bolts. I said, okay, cool, let's learn Bolts and see what happens. The last commit was in January 2016. Ivan said that's because it's stable. I said it's because probably people would lost interest in that. That's debatable. There is definitely some learning curve. As always, with a new framework, you have to familiarize yourself with the concept of task, continuation, all that stuff. I'm jumping this for a while. So tasks are hot. So whenever you call a task, it starts doing its work. Right? There's no concept of cold tasks in Bolts, so you call, start working. It might not be what you want at that particular moment in time. Now, bolts cancellation API is weird. If you do need to cancel a request, requests are not cancelable, tasks are not cancelable. You have to pass a different object, and then you have to cancel that object, and then the task has to query the object to see if it's canceled, and if it's canceled, the task can be set canceled, and yeah, it's weird. Okay. Okay. Can we do better? Well, I hope so. So the next solution is going to use a framework that may be familiar to a bunch of you guys. We're going to try and use Rx Java. A bunch of people is using Rx, right? So for those who never heard of Rx, Rx is a framework that uses the concept of observables, which essentially are a stream of events that happen in time. An observable is something that, given a time frame, will emit items, right? We have the same repository over here, the same operations, but now we're returning what we call a single. A single is a special observable in Rx2, it's not present in Rx1, which will either emit an item and finishes, or it will fail. So for those of you that do work with Rx, singles do not have the onNext method. It's just uncompleted with the item or on error. Okay, here's our code. Now there's a bunch of stuff happening here. So we start by fetching the customer, and once we get an observable with that customer, we call flatMap. FlatMap is an operator which will get one observable, and it will return a different observable that will emit a different type of item. Once we get the customer, we're going to fetch all the orders for the customer. And remember, these are observables, so we will return one observable per order, right? Once we have all those observables, we're going to call merge. Merge is an operator that takes a bunch of observables and will create a single one that will emit all those items. So if we had 10 orders, now we have 10 observables. We're going to call merge. Merge will give us one observable that will emit 10 orders, right? These are new observables, so Rx always returns new things. They're all mutable. After we have merge, we're going to call toList. toList is a new different operator. toList takes an observable that emits a bunch of stuff and returns a new observable that will emit one list with all those items inside, right? In parallel with all this, we just fetch the checkout. So all of this is happening at the same time. And then we're going to call the zip operator. Zip is similar to merge, but it can work on different types. Merge can only work on observables that will emit the same type. And with zip, we will accept a bunch of observables as input, and we will accept a function as well, which will convert each of those items to different stuff. And in this case, we have a list of orders. We have one checkout, and we're going to create our customer info object, passing all the stuff. And zip will return one new observable that will emit this customer info item for us. Okay, finally, we will post the results on the main thread. So that's it. Everything here is happening on different threads. And we call subscribe, which is Rx's way of saying, hey, do start working for me. Because if you don't call this, none of this will ever start working. Okay, so what are the pros and cons? So first of all, Rx is compositional as well, like bolts. But Rx is more compositional because we have more stuff. And it's more neat than bolts. Rx is immutable. Bolts still have some state to save. They actually have an operator that saves state between calls. But with Rx, everything is a new observable between calls, right? So no state, no problems whatsoever. Rx is very flexible. We have like 10,000 operators that you can do whatever you want with that. And observables are called by default. So you can write all that stuff and just call when you are ready. No need to rush, no need, oh my god, I'm already calling network and all that stuff. Rx has a steep learning curve. Like, I remember when I tried to introduce Rx to my team back a while, it took the guys a long time, at least 2 to 3 months to understand at least like flat map, and all this stuff, because it's there's a bunch of things happening. They're not that dumb. Rx is a very big library. The last time I checked, it was over 3,000 methods. So if you are, okay, we can use multi-dex and all that stuff, but this is something that you take into account, right? This one is a little bit more, not on the technical side, but Rx is a very powerful library. But sometimes people use it just to chain network calls, which is like using a bazooka to kill a mosquito, right? Rx is very powerful, and if you architect your app around it, it will be very nice and clean in a reactive approach, so to speak. But it might not be feasible if you have already a running app and say, hey, let's change everything to use Rx. And finally, Rx is not type safe for errors. All observables emit an error of the type throwable. So if your network crapped out with a 404, it's going to be a throwable, right? If you have a business logic, if you have a business logic that throws some error that your company recognizes and works on, it's going to be a throwable. So, yeah. Thanks.
All right. Thank you, Francisco. So, yeah, as Francisco mentioned, that the Rx is actually quite big library, and it's very powerful. But the question is that, like, we are solving one particular problem of the continuation execution here, and do we actually need to use the whole Rx just to solve this problem? Probably not. So what we can do is use promise. Promise is well adopted in JavaScript, but not so great popular on Android. And what means promise is that it represents the result of some asynchronous operation that eventually will be resolved with some value or will be rejected with some error. So usually it's like, not usually, but actually it's like two states. One is successful and all rejected with some error. At Shopify we have our own implementation of promise. It's completely written on Kotlin, and inside it contains very simple state machine with like 4 states, like idle, doesn't do anything, like pending means that executing, resolved, or cancelled. So the concept behind the promise is very simple, but at the same time it's very flexible. So our the base core implementation of just one class with 200 probably lines of code. And why it's so flexible? Well, basically it's a monad. So what is monad is basically like you can create a promise with some values, some like constant value, or you can wrap some asynchronous operation with a promise. And it has one special function that is basically a flat map. So the flat map is basically allows you to create the chain of the promises or tasks. It's very powerful. It's actually used in Rx as well, and pretty much everywhere. Like when for inside the Facebook goals, in Kotlin coroutines. So it's strictly type safe for both for the success value and for error. So it's unlike the Rx where we just have a throwable and it can be anything. Here you create a promise and specify the exact type for the result and for the error. So you can easily create a chain of the promises, and yeah, so let's see how we can solve our problem. So this is our repository. We have like again the same functions, and now they return a promise that in like several cases return a customer checkout order, and we specify what type of error we have, and this error is actually a project object. It can be anything. There is no like restriction to make it only throwable or exception, so it can be anything. This is our solution for our problem with a promise. So let's see line by line. First, we of course fetching the customer ID, and it returns us the customer. So we are using this then operator that is basically a flat map. What is a flat map? Is a function that takes another function, and this closure is actually, it has one argument, the result of current execution promise, and it must return a new promise. So let's see how we construct a new promise. First of all, our customer has the order IDs. So what we are doing here, we just map each order ID into another promise. So we're creating a list of promises. Then we use the promise all. So basically we are combining all the list of promises into one promise that will return the array of orders. And of course we have the same error. For the checkout itself, it's pretty much straightforward. It just returns a promise that will be resolved with the checkout. Now we need to combine all of them. So we need to combine the checkout and orders promises. So we use again the operator promise all. And we apply the map function that is basically just like mapping one value to another. And as the argument for this closure, we see this is a tuple, that the first item will be checkout and the second will be the array of orders. And we just creating the customer info with all this information. This one is pretty much similar to what we have on Rx. We saying, okay, we want to complete on main thread, and this when complete is actually who is triggering the promise. So basically, promise by default is called. So whenever we declare the promise, it doesn't do anything. It's just like in idle state. And first function that calls when complete is actually triggering all the chain execution. And at the end, we have provided the closure that will take the result as an argument. So this is a result of the execution of the whole chain. And the promise can be resolved with these two states. It can be success or it can be an error. And in case it's success, we show the customer info or show the error. And everything is made on the main thread. What are the pros and cons? Well, lightweight library. Like for instance, like we have all operators combining, scheduling. They are basically extension functions that using just one flat map operator that is built in on the core. It's type safe, as we saw that you must provide the type for your success value and for error as well. Flexible, as we saw, you can even write your own operators. It's very easy, and it's easy to chain as well. We saw that. So what the cons? Well, it's a single value resolution. So what means promise result and you're done. It cannot emit like an Rx multiple values. So it's just one value resolution. If you need to repeat the same promise, you need to create a new one. It's kind of hard to debug. I believe the same applicable for the Rx, because if you create a huge chain of like tasks, it's very hard sometimes to find what they happen like in the middle when some task like failed. And of course it's some learning curve because you need to like understand how it works, and especially you need to find a way how to, if you want to convert some types. Like if you want to convert from one type to another type, you need to think about not only for the success value, but for error as well. All right, so what we have else? Well, I hope all you started looking into Kotlin. And the Kotlin actually provided the interesting new stuff, like a Kotlin coroutine. So basically, it's not a new the approach, but for Java for sure, it's a new way to work with the asynchronous operation. Here's all our code. Let's see line by line what's going on here. So now our repository is actually returning the customer, straightforward. But look at this. This is a suspended function. The suspended function means that if this function will be called on the coroutine execution will be suspended. So let's see how it works. This one is actually starting the main coroutine by using the launch, and in the argument we are providing the context. This one. Context is basically the thread pool. So in our order it's just like UI. So that means that the all code in this closure will be executed on the UI thread. So like show customer info and show error will be executed on the UI. This is the way how we actually handle the error. So just like as a plain synchronous execution, just a try catch, everything has happened here, we catch the exception and show the error. Now let's see how it works. So this line is actually we are calling fetch customer by ID. And because this is a suspended function, this is some special function, means that the execution of this main coroutine will be suspended until we will fetch our customer. But suspended means it's not blocked, so the UI thread won't be blocked. So we will suspend execution of this whole closure until the customer will be resolved. And that's what we need. We need first, it's the customer. The next one is actually we want to fetch the checkout. So we are fetching checkout by ID. It returns is a suspended function. But the idea is that like we don't want to wait to the checkout because we want at the same time fetch the orders. So that's why we call another coroutine, asynchronous coroutine. And that means that the main coroutine won't be blocked. And as you notice that it returns as the deferred, that means the object that will eventually resolve with the checkout. So the main coroutine continues execution, and the next one we are doing with the orders the same trick. So we are creating the async another coroutine and the calling the fetch order by ID, it returns us the list of deferred order. So everything is scheduled and we still continue execution. So, but now we already scheduled the checkout and orders to be fetched. We need somehow to await for the results. And this is a wait function, it's suspended function on this object. So basically what means that this code will be suspended, the execution of coroutine will be suspended until we will fetch checkout and orders. And we just like when we finish when we fetch checkout and orders, we just create a customer flow and show the customer flow. So what the pros and cons of this approach? Well, it's minimal, low-level API library. It's a library. So I believe it's only one keyword suspended, and everything is built as a library. So you can even implement your own coroutine implementation. It's actually not so bad. You saw that there is no callbacks at all. It's just linear async style. It's like a new style of the approaching the asynchronous operation. I saw this a lot of places that coroutine is called like lightweight threads. That's not true. I wouldn't call that because internally the coroutine uses the same thread pool as any Java, standard Java. The only that it's like how the coroutine organizes the execution of tasks. So it's like, the benefit of coroutine is that like it improves the utilization of the threads. You can schedule a lot of coroutines at the same thread. The next one is the highest complexity of Java concurrency. That's true. We saw there is no synchronization, no the mutable, locking, all the stuff. So we just write as a linear code. And this is the most concise way to solve our problem. What the cons? Well, learning curve for sure. You need to understand how it works, because internally there is some magic going on. And compilation time, the coroutines actually transform your coroutine execution into state machine, and basically internally it creates the code that is basically create this chain of callbacks. So you need to understand how it works in order to, like, I don't know, find some issues if you have any. And another way is that there is no model of the problem. So basically what we saw that with Rx, with the promise, the fetch customer info is returns of the promise. So this is our model. Here we just like implement the linear invocation of suspended function. So there is no real model for that. I found like, I don't know, maybe I didn't search now, but cancellation of blocking API. So with promise, let's say, or even with Rx as well, you can register some action that will be called when this promise or Rx will be cancelled, and that will give you a chance to block, let's say, a network connection, close the network connection. With coroutine, there is a like workaround for that, but it's not easy to like, okay, close the connection. Well, because there is no model, it's very hard to abstract the model. And the last one is the experimental. Well, even though JetBrains says that you can use that in production, it's still marked as experimental. Maybe because they want to keep the right to change the API. That's what happened with the first prototype. Then they have the second one. The API changed a little bit. So what's the next solution? Well, Java 8 has completable future. This is our repository, so now we, as a, like, with the balls, with the promise, it's just a completable feature that will result with the customer checkout order. This is our solution. Again, pretty much straightforward. We're fetching customer. This then compose is basically a flat map. So we accept the customer and we need to return another completable feature. So how we construct it. The similar, so you have the order ID when creating the list of the completable feature for fetch orders, for checkout, straightforward. And now we need to combine together the list of completable features for fetching order and the fetching the checkout. So this is like the all-off static function that accepts the array of the completable features, and it will wait until they all resolved. So then we then apply is basically a map, and we map in the recent implicit parameter it that is basically we'll see. So this one actually is weird function. So instead of like returning you like some type of, I don't know, array or tuple, it returns to you a completable feature that just notifies you I'm complete or not. So that's why we need to get a checkout. That's why we call the join on checkout and orders in order to get the order and checkout. But because we already finished, this join won't block, it will just return the value. And the same stuff we have like with Rx, with the promise, when complete, is basically our callback mechanism to get the customer info or error. And because this is a Java 8, it doesn't know anything about UI thread, so we need to wrap that in UI thread. And we are showing error or customer info. What are the pros and cons for that? Well, it's built into Java SDK, and it's built inside the Java, so I guess there is no issues with that library. I can trust. It's quite a lot of method there. You can basically solve any of your case. Well, learning curve for sure, because sometimes it's very weird API, I would say. And again, the same as like with balls, there is no called features. As soon as you create a feature, it starts doing the job. Yeah, as I said, it's strange API. We saw that like flat map, they call it differently. map they call differently, and it's like at the same time it's a bloated API. You have 50 methods. Like, what can he do with this 50 methods? I don't know. Like, why do I need all of them? And another one is big one is that it's like on Android you can use only starting from API level 24. And the last solution, well-known Google Library. They have own implementation of the future that's called listenable future. It's basically a wrapper around the existing Java future. So again, straightforward, we return the listenable future. And this is our code. Let's see what's going on here. First, we are returning the future that will fetch the customer by ID. And then we need to transform this future using this transformation to get the customer info. So let's see what the transformation is. The transformation is actually an async function that takes the customer and it should return another future that will be resolved as a customer info. So here we have a customer. The same trick we're doing here. We map the order ID to the futures, and it will be a list of futures. Then we're going to use the grouping, combining, so successful as list. So it will return us a listenable futures that emits the list of orders. Checkout straightforward. Then we are combining together the orders and checkout using all as list. Is basically again is just a map, and we are using the transformation function, and that takes another function to actually transform. So we are combining the orders and checkout. Because this one is actually returns you the list of objects. That's why we have to cast. So we know that as the second parameter is going to be a checkout, so we cast as a checkout, and the first parameter will be like a list of orders. So that's why we're using the casting here. And basically the same stuff. So we have our final future, and we this is how we actually listen for the execution. When it completes, at callback, we provide a callback, and it notifies us about success on failure, and we specify on which executor we are going to show this stuff. Pros and cons. Well, it's well-known Google Library. It's just a wrapper around Java future, and there is no actually fluent API, so we saw that everything is done through the static function. So it's kind of some boilerplate code here. And again, the same problem, no error type save. So as we saw that you just got a throwable. And the verbosity, so we saw that how much code we wrote that to solve our problem. And again, I guess we have all known about that. It's quite a large library, so you need to be aware of that. Yeah, this is all reference that we use. You can check it out. Yeah, that's all that we have. Thank you all, guys. And you saw that we have a lot of different approaches to solve this particular problem. And our job as a developer to pick the correct one to solve the particular problem. Yeah. Thank you.